So hello, thank you all for coming. My name is Keith, and I work at Torch 3D. We are an AR startup out of Portland. We build a end-to-end mobile tool to publish and create interactive interactive AR content. We will soon be publishing to the web, which is why I kind of got there. But today is, I want to first mention that it's a very special day today because when I got the notification that I would be coming here to speak, I was like, yes! And then I looked at the date, today's date, and said no, because it happens to be my wife's birthday today. So I'm missing her. She's across the country, or across the planet. And I wanted to, so when she's looking at this on YouTube later, say, happy birthday, Chris. I love you. Thank you for believing in me enough to come out here. But I also want to thank everyone here, taking time out of your lives and your families and jobs to come and hear someone you don't know talk about a bunch of weird stuff. So what I'm going to talk to you about today is a story about humans. It's super obvious and easy in our industry, in the AR, XR industry, to think about all of the different technical ways that we could solve problems. But at the end of the day, every single one of us is a person, and we're the ones actually using the technology. And so my background, coming from print design and having a little foray into software engineering, realizing that I didn't actually enjoy technology for technology, I enjoy it because of what it can do for us and how we can interact with it. I approach my job at Torch in a way that always takes the human perspective into account first and the technology into account second. And last summer, a coworker of mine shared a project with me. So Torch began as a rapid prototyping tool. It still is very much the same thing. You can build AR experiences very fast, no code. And we often share these with each other so we can get feedback. My coworker had sent me this project, and I did what anyone would do. I pull up my phone, I start scanning, I find a plane on the ground, and I tap to set an anchor. So the anchor, it's markerless. The anchor is where the whole experience is going to be bound to. And the text on the different cards that she had set up was just really small, and I couldn't even read it, right? And this is a common problem in AR that doesn't exist in other media like screen design. So my first thought was, I must have done something wrong. This is my fault. Okay, I didn't set this in the right place. I'm not standing close enough. I did something wrong, this is actually a really strange question to ask ourselves, right? I mean, we interact with things all the time that break. And how often, for example, do you pull up a Google or some other web page? Google doesn't go down very often, but you pull up a web page and an image doesn't load or content doesn't load, and you go, I wonder if I did something wrong. And it's not something that we ever ask ourselves or say because we know that websites break. We know that network is a problem. But because AR is kind of unfamiliar territory, we get into this area where we're not exactly sure at times what is happening, why there's a problem. So I started troubleshooting what was going on. I said, okay, maybe the anchor found a plane that was below the floor. Maybe it's too far away. So I tried to set the anchor again, and I got the same problem. And that was because after resetting the anchor, it did land in the same spot, and I wasn't moving. I was just sitting in my local space, okay? Local space is what I call anything that goes to the tip of your finger to about where you lose focus. This is our primary interaction zone. But the problem with troubleshooting AR in our local space, which is something we could do on our phones, is that in AR you have to move, okay? We exist inside of AR. So moving around is the next step, and that's exactly what I did. So I got closer to it, and as I got closer, it's not just that they're big and super far away or tiny and super close. I'm just not in the actual proximity I needed to be in to see these things properly. And part of the problem with mobile AR especially, this doesn't happen with Magic Leap or headsets like HoloLens as much because you have binocular focus. When you're looking at AR through your camera lens, your camera, regardless of whether you have 1, 2, 3, or 5 cameras on the back of your phone these days, it's flattening everything down into a screen. And so basically what's happening is it's turning you into a cyclops. Everything is flat. You have monocular vision when you're looking at a screen, so you lose things like depth cues. that tell us in real life how far away this bottle is. An example of this is the parallax effect. So these two balls, set up by the same coworker, actually, thankfully, they look like they're the same size, but as you rotate the camera around, you can see that one's actually much closer to the camera than the other. But because the screen is flat and because we don't get those depth cues that we have with our, able-bodied people have with two eyeballs, they can seem odd. We don't necessarily understand the relationship that our bodies have to the content that we're seeing. So I took a seat to think, and again, as I sat down, the content got closer. And then I stood up. Oh, whoops, that was too fast. I sat down, the content got closer, and I stood up, and then it got farther, and I sat down, it got closer, and I started thinking, oh, this is interesting. There's a relationship between me and the content spatially, right? But we could look at this as a surface problem, right? So Unity is looking at Mars, right? I don't know if you're familiar with Mars. Mars is an augmented reality system that is being developed by Unity that's designed to target content to, say, a table. So this content will always appear on a table. And so when I'm scanning a room, it can find a table and place the content on that table. It doesn't have to be the same table I designed it on, but it knows that the camera knows that it has to be bound to a certain area. But the problem with that is that I'm not a surface, I'm a person, right? Okay. Content is another problem. Microsoft, I forget exactly what the acronym is, but has a content system that's designed to, this was some research that was done in the ancient days, like 2016, where they're looking at area, and they use surface points to gauge, is this enough room to make this content fit? Can I rearrange the content to fit in some other area? But again, I'm not content either, right? I'm a person. And in any AR experience, I'm the one that is the wild card. I'm the actual variable that none of us in this room can account for when the AR experience launches. This is different from this device or laptops because we can form-fit things to these. And we know that even though we're all different sizes and shapes, these are all pretty similar. The other problem with approaching this from a technical perspective, which is, a thought that came to mind, is that the future is persistent. We just heard this in the last 10 minutes. When we start designing persistent content instead of content that's markerless and just placed wherever you want, the content will always be on this podium, for example. I know because of GPS, because of surface features, that it will always be here. So the actual real problem of how to gauge the content for the user is the user's proximity to this thing, not the size and shape of this. So for me, this is a study in ergonomics. And when I'm saying ergonomics, what I'm talking about is the relationship and the physical attributes that we have in the environment interacting with physical objects around us. Obviously, AR objects are not physical, they're fake. Well, virtual, but they act as physical objects in our environment. So our posture, our stance, our seated position, those all come into play in how we actually experience these things when we launch an AR experience that someone's created. Tony Parisi from Unity, great guy, recently just said in an interview that we don't understand the ergonomics of how to interact with this content yet. I think he's wrong, but I think what he was talking about is something different from what I'm talking about. He's talking about these kind of ergonomics, like pinch gestures and zooms. What is the analog for a mouse in AR? But I'm talking about macro ergonomics. So the idea of our bodies in space, how we exist in an AR experience, how we come into the experience, and how we exit that experience. There are 3 spatial regions that we can interact with content in. We do it every day. We don't do it on our phones every day. We do it out in the real world. Local space, like I mentioned, is this kind of sphere around us that extends from our arms to where things are too blurry to be able to interact with. What I'm calling proximate space is kind of to the edge of our depth perception, where we kind of know how things are positioned and situated with respect to our bodies in space. They beckon us to go interact with them. And then remote space, which is everything that's very far away, or let's say further than 10 meters away, that we can use as markers and waypoints to guide us around space. And in looking at these three different zones and all of the stuff that I've already been talking about, it occurred to me that responsive AR is possible right now with tools that we have right now. It's not a perfect solution, but we have a way to start figuring out what are some basic mechanics that we can employ in AR experiences to start creating content that reacts to us a little better, that gets us a sense of engagement right from the bat, so we don't ship out a filter to some 20 million people, and their first impression is, did I do something wrong? Where to begin? This is a big question. I don't know, it's a big subject, so I started with something that I was familiar with. Again, I used to work as a UX designer in the digital space, screen world, and so I started there. Whenever I don't know how to do something, I go back to an analog that I'm familiar with. Anyone know who this guy is? 2011, this man, Ethan Marcotte, wrote this book called Responsive Web Design, which is the foundation of every mobile page that we look at, every desktop page that's well-designed that we look at these days. He just kind of came around and said, hey, have you heard of responsive web design? It's this thing, okay? We don't need new technology. We have the technology already. Is it perfect? No. Is it a concept that we can work with to create better experiences on the screen? Yes. And it's a good thing because this number, 63,272, is the number of device signatures that Scientia Mobile detected in 2019. They didn't detect all these at once. It was the 63,272nd mobile device that they detected. That's a lot of screens. Obviously, iPhones are designed in a standard way, so most of those they can account for, but there are a myriad of other possibilities between tablets, laptops, desktop screens, TV monitors, iPhones, mobile phones, etc. That's a lot of mobile device signatures to account for when you're a designer working on a web page. We can't do that. That would take way too long for us to work on. So the question is which device? And the thing that Marcotte brought to the table was we don't need to know which device. We just need a set of bounds that we can use to adequately provide people with content. And that's the cool thing about websites now is that based on this framework, it's evolved quite a bit. And I don't think people design websites today like they did in 2011, nor do they build them that way. But websites handle context for us. Okay, so am I on my phone? Am I walking down the street? What's important to me when I'm mobile and I'm looking at a web page versus what's important to me when I'm sitting down at my desk in my office? That's what websites do for us, and that's what responsive web design gave us. And it took all of that complexity of all of those thousands and thousands of devices and reduced them into 3 or 4 or something like that. Most people nowadays would say 3 devices is enough, especially if you're someone who's designed board after board, building website comps, it's plenty, and developing them as well, I suppose. But the problem with the screen as an analogy to this problem that I was having with an AR experience is that it's very limiting. Okay, I can't get behind my, I guess now they make phones that have screen. Anyway, I can't get behind my phone and see content, okay? I can't go into the content. It's there. I'm always looking at this from the same perspective. It's always top down, right? One perspective onto the screen. 2D is our flatland. It's the place where we can design content and have a pretty good idea of how it's going to be seen by any given individual because it's always on a screen. It's one perspective. And this is what happens, right? This isn't only what happens, but you get these kind of memes that pop up where people are using depth and the loss of depth through monocular vision to do fun stuff like put the Leaning Tower of Pisa on an ice cream cone. But if you could get into your screen, into this scene, you would see that, which looks hilarious to me. Just a bunch of people standing out in, can you imagine? No, it's a lot different. Reality is much different than we are presented with on the screen. And the thing about AR is that it's bringing us much closer to that three-dimensional perspective that we have when we walk around the planet. We don't share the screen space. We touch it. We look at it. We observe it, but we can't share it. And that's the main difference that I'm trying to get to with AR. And that was the part where I broke from my analogy and said, I need to start thinking about this in a way that involves my body and involves the space around me. The thing is, we participate in AR. We don't observe it. It has to be something that we can engage with and move around, touch, stare at, walk into proximity of, unlike a screen. We're present. We talk about presence in AR. Once presence is broken, the idea that I'm here and that thing is there, not I'm looking through a screen, but it's actually there. Once that's broken, the AR experience starts to fall apart and we just get graphics on a screen. And the most important thing out of this is that our presence alone inside of an AR experience changes that experience. Because none of us are the same. We're not shaped the same. We don't think the same. We don't look at things the same. We don't necessarily decide to all stand when we look at an AR experience. Our presence changes the perception of what that experience is. And there are a lot of unique perspectives on this planet, right? Almost 8 billion of us walking around thinking differently, looking differently, acting differently. Different sizes of people. So someone might be this tall. A friend of ours from the Netherlands, he is a very tall man. So when we test AR experiences, it's really fun to pass it to him because his perspective on it is quite different from mine or my partner Tara's. Where we have different abilities, some people can't even stand. Okay, so when we're designing AR experiences for everyone, how do we think about it in terms of, well, what if someone's sitting in a wheelchair or just merely sitting down? We are different shapes, different cultures. We look at symbols differently, right? So as we're designing content based on our cultural background, we might see it differently. Different genders and different ages. So there are a lot of these, 8 billion people. This is not even the start of the list of differences between us. There are a lot of variables we have to account for, many more than the 63,000 devices that are out in existence. I think it's something like 121,000 times more. So it's a big challenge. It's a huge mountain to climb when we're thinking about, all right, I'm going to start planning out an AR experience that I want to build. I have to think of all these things. So this is actually where I call back to the analogy of responsive web design and start thinking, well, we need some way to simplify all of us down into a general set of variables that we can control for. Didn't know that slide was coming. The point is that AR is sphere land, right? It's 3 dimensions. It's end perspective. Every single one has a different perspective on the way the content comes out. So if responsive web is for screens, responsive web has to be for people, right? Because we're the ones who are spatially involved with all of this content. So back to the problem at hand, the challenge ahead is kind of big. Okay, I have to solve some problem that has so many variables that I don't even know where to start. We have runtime variables. Am I standing? Am I sitting? Am I walking? Am I lying? I don't know. You might lie down to look at an AR experience. Maybe. We need a responsive web type simplicity. We need some way to constrict the randomness of some person that we don't know from a part of the world that we don't know. We need a way to restrict their experience in coming in so that they achieve something closer to our vision. And we need something that's cross-cultural. A gentleman on Twitter, of all places, started telling me, well, use the force is cross-cultural, and that's not something that we naturally understand. And my point was that it's cross-cultural, but we don't conceptually understand what that means. Okay, so what I'm looking for are mechanics that people understand. It doesn't matter where you come from on the planet. If we speak the same language or we're using Google Translate and I ask you to pick up this bottle, every single one of us has a discrete list of steps in our heads that says, okay, stand up, approach bottle, grab bottle with hand, pick it up. That's cross-cultural. So use the force is something that is kind of quasi-cultural, I guess. And I guess to hit this nail on the head again, our ergonomics, the way we enter into an AR experience, they alter our perception, right? So imagine there's a person standing looking at an AR experience. This is not me, but this is me at the beginning of the story. I had put this experience on the ground. This blue shape at the bottom represents the anchor. Where did I place the anchor? I placed it on the floor. I was standing up. If I imagine that there is some sort of like red disc or a plane that's sitting at some distance y from that anchor, it's looking like it's hitting right mid-belly for this posture, this ergonomic posture. But again, someone who's unable to stand, looking at the same exact anchor on the ground with the same disc that's positioned the same height off the ground, will see that at eye level. This is a very different experience for both of these people. They will perceive the content in this experience in different ways. The location of content, as we place it in space, also changes in turn our perception. This lady is standing at a table. There's an anchor on the table. She's placed this experience's anchor on the table. There's that disc again. Same height away from the anchor. It's at eye level. And here we have our seated person again. Same content, same distance from the ground. They're both at eye level. So where we've placed the content is changing based on how these two are positioned, their ergonomic relationship with that content. And so placing that content at a certain height will change the way people perceive it. So this is me on the right. And this is where I was supposed to be on the left. It clicked in my head that, okay, what the intention behind this design was that either I was seated or that I had placed it on a table. And I did that. All of a sudden, the content was very, very legible, right where it needed to be. And so, to me, what this means is that our perception of content is a function of where we place that content in space and how the viewer is positioned in space with relationship to that content. So ergonomics and placement are the two things that need to be accounted for to solve this problem. And so I came up with a limited set of ways that people might be standing or sitting, and a limited reasonable set of where they might be placing content. Now, this, tabletop and ground are two very common places that we see people placing content in AR. It could be on the wall, but the distance between the camera and the anchor is really the main point. So if you want to translate this 90 degrees, it's fair, and it works all the same. Okay, but sitting, looking at content on a tabletop, standing, looking at content on a tabletop, sitting and looking at content on the ground, and standing and looking at content on the ground are four different major conditions that I know about through working with people and working with Torch. And I like graphs, so I put these on a graph for no reason other than to put some numbers into this presentation. And I gave sitting and standing a +2, -2, because those have much more variance in terms of how they could play out. For example, a very short person standing up versus a very tall person standing up. Whereas tabletop and ground, obviously ground is always where the ground is, and tables have kind of a standard height. So I give them a little less number. It's very technical. I added these up and I came up with these three locations. You have up close. So this would be something like sitting down looking at content at a table. You're as close as you can possibly get to the content. There's middle ground, which is either standing and looking at something on the table or sitting and looking at something on the ground. And then there's far back. And this would be standing looking at something on the ground. And these numbers are I just added up those ends of the poles, and that's what we get. And it's important to note that the middle ground is a ±1. This is about the same. This is that, back to the slide with the lady sitting and the lady standing. Even though they were in different ergonomic relationship with the content, they were kind of perceiving things at about the same level. And so these are my three cases. I've got super close, again, looking at something on the table while you're seated, standing and looking at something on the table, and then standing and looking at something on the ground. And in my head, I said, what if we took that disc, I'll bring the disc back, and what I want to do is I kind of want to create a 0 point for all of these people. So I want to put this right beneath the camera, so that for each of these individuals, that disc is related in the same way to their individual phones. And then I got rid of the people, and I mapped these over the top of each other, and I said, okay, I've got 3 different heights with respect to a single anchor. This is perfect. Those are the breakpoints. This is my connection back to responsive web design, where I had this idea of, okay, I can boil ergonomics and content down to a very small set of breakpoints that I could use to change content as someone enters into an experience. So, like I said, Torch started as a prototyping tool, so I did some rapid prototyping that I sketched out thusly. I need a scene for each one of these different scenarios, okay? I need a scene with the content in it that's related to someone who's far away from the anchor. I needed a scene for some people who are in the middle, and I needed a scene for people who are up close. The next thing, I had to build a 4th scene in Torch that contained these breakpoints. So those red discs at those different heights, those are my breakpoints that I would render as physical planes in the environment. And then I needed an interaction triggered off of each one of those planes that would send me to one of these breakpoints if I hit it. And then I just needed a way to open in on this scene so that right when the anchor is placed, these interactions fire and I get taken to the correct place and see the right content. 4 scenes is all it really takes. I will admit right now, this is very hacky. This is not a long-term solution. But this is something that in the interim, while I'm trying to figure out how responsive content can work in AR, it's a way to get there. It's a way to start experimenting with it now without having to build a huge technical solution to it. And so here's how I made it work. I took those 3 dots, or those 3 discs, and I mapped 2D planes to their heights. And again, this is where our Dutch friend Martijn came in and hooked us up, because he was very instrumental in testing what is the highest threshold you need for someone who's about 6 to 180 centimeters or something like that. And then I took away all that stuff, and I angled these planes out, right? And so when you enter into this first scene, as soon as the anchor is placed, your camera will be looking right through all 3 of them, except that each plane occludes the next. So if you're standing and looking at this top one, you won't see the bottom ones. If you were sitting down, or if you raised that anchor up in space, this would be the first one you'd see, because that top plane would have gone above your head. Because remember, you've moved closer to the anchor, which is the same thing as moving everything up in space. And if you were seated and looking at something on a table, both of those first 2 planes would be above your head, and you'd be looking directly at this lower plane. But we need interactions. You can't just look at a plane in space and have it do something, right? So there's this trigger that we have in Torch called gaze at. Gaze is a pretty common trigger in AR. And it works perfectly, because what it does is, as soon as the camera is looking at the center of an object, it fires. And they're fast. So fast it got there before. Anyway, they're fast-moving things. So it's instantaneous. There's no space in between when the camera recognizes the center of an object and that trigger firing. Well, it's probably a frame, but faster than we can process, right? So if I'm standing looking at these planes, I'm going to fire this far back scene, and I'll get shot into that first scene. If I'm seated or standing and looking at something on a table, I will first see through this middle plane. And if I'm looking at something on a table in a sitting position, I will first see through this bottom plane. I had to make these planes pretty big. I think they're many meters across, because I didn't want to have any kind of error on how the camera sees it. If it's not like kind of near the middle, it doesn't work all the time. So I made them pretty big so that instantaneously, immediately, you would be looking through a plane and firing that trigger. So that's pretty much the entire mechanic of how I built this prototype. And then there's invisibility, which is super great for this, because again, so like presence again is a major part of AR. We don't want to go into something and know that we're looking at a screen. We want to feel like what's happening on our screens is happening in front of us. So I mapped transparent pings to all of these planes so that they're not only rigged with interactions to take me to the right scene, but they're also completely invisible. So that literally the moment you drop into my project, you're taken to the right place. So let's see it. I'm not doing live demos, so I got a video. What I'm going to show you is basically I've got content that I'm placing in multiple scenes, the same scenes we just talked about. And I'm going to first be seated at a table, and then I'm going to stand up at the table, and then I'm going to swing over to the ground, and you'll see that the content changes each time. So here I've placed this, designed for close-up viewing. Standing back in space, I place the same project, and I get a different set of content. And then swinging over and resetting the same project, I'm not changing anything about the project, I'm just mapping different anchor locations. So this is all happening instantaneously as soon as the experience is launched, which is great, because that means that I no longer have to account for how someone is positioned with respect to the content in this project. So this is a template that's available if you use Torch. If you don't, you should go download it because it's great for building interactive AR right in your hand or on a tablet. We're soon going to be rolling out web AR publishing, which is going to be awesome. So you can go directly from the app to the web with a touch of a button. But you can start playing around with this right now. And the question is, what can you do with it? In this demo that I just showed you, and I've got a couple coming up, the content's kind of placed in a similar size, which is a little silly because if I just wanted it to always be the same size, I don't know, it doesn't make a very, well, it maps to the way people are positioned when they open it, but it's just not expanding on the idea of like what can responsive content do in AR like it does on a desktop. And one concept was, let's say I'm standing here at this podium and I open up an experience about Kew Garden, and I can see the whole garden mapped on the table with different markers of where waypoints are, information markers. But if I swing over to the floor and place it where it's far away, then I can get an actual life-size version of it that I can walk around. So in this case, what's happening is I'm not just making it so the content's the same regardless of whether the anchor's placed, but I'm saying what's the context in which someone's looking at this, and how can I change that content within that context so that it's more meaningful to them at that moment. So that's macro ergonomics. Again, that's my buzzword for how we position ourselves with respect to content in space. Relative positioning of content. So those three planes, again, they are being positioned relative to the viewer because of the viewer's relationship with the anchor. And physical breakpoints to make actual pathways that we can route people to get the content that they're looking for. Transparent interactions is also very important. So things we need, like using techniques or using triggers that don't break the film of reality, right? We want them to feel that presence when they get into an AR experience. And that's a pretty great start. Again, it's super hacky. It's not technical. It's not going to stand up to, I wouldn't say it's entirely scalable. But it's something. It's a way for us to start exploring and experimenting with how content can be more responsive. The end. Question mark? No, it's not the end. This is bonus round. And I call these bonus rounds because I didn't practice these at all. I added them super late, so let's see what happens. So it's really great that I can make this experience where when you enter it, it responds and reacts to your posture and sets the content up in a way that's more meaningful to you at that time. But that's pretty static. Okay, if you have to reset the project every single time, then you are not getting the full experience because, again, AR is about movement. The interactive space that I talked about earlier, right? We have these three regions, and in the world, we like to use them. We don't stand in one spot all day. So it's important that in an AR experience that you be able to move, that you have agency of movement. So The idea that content can be dynamic is pretty important. It's kind of like imagining a web page that you drag the page open and close, and the content kind of mushes and changes based on the size of your browser. So this is the little fellow that I had in the video I just showed you. And what I did was I took what's our enter proximity trigger and exit proximity trigger. So these are triggers, these are other interactive triggers that we can use in Torch that exist in other frameworks as well. But I imagine, like, okay, if there's a sphere around this little model, and I set up triggers so that when I go into its proximity or away from its proximity, that the content starts moving and changing. And I use those same exact breakpoints that I used earlier. It's something like 1/10 of a meter, 6/10 of a meter, and 1.1 meters. So I created proximities at those distances and made scenes where this distance r from the center of the sphere out to the edge was mapped to those breakpoints that I designed earlier. So, for example, this r is the distance from the middle ground plane to the anchor. So this is rapid prototyping number 2. I just took my same sketch. I said, okay, now what I need is I need interactions inside of these scenes. So I need to actually take the content that's in the scene and create interactions on it as opposed to at this outer scene out here. And I needed transitional scenes that go in, but you can see how messy this starts to get. But I needed transitional scenes to go in between each one. So I don't want the content to just jump back and forth. I want it to transition, right? I want it to feel natural. So now I need 8 scenes, which makes this considerably more complicated than the last one, but also doable. It's possible. Let's see it. Here we go. So this is it, and basically I'm just going to walk up to this thing and walk away from it. And the little tabs on the right will jump. But so now we have content that can respond to movement as well as placement. We have a way to interact with people at the beginning of the AR experience so that they're not lost when they get there, and we have a way to change based on their behavior once they're in, which is super cool. Bonus round 2, image tracking. I was like, what if I put images in the scene and start using those as anchors instead? Which is pretty great. It turns out we can use image tracking to create this kind of response as well, which is super nice. Because it turns out images can be anchors, right? In Torch, you can swap out the anchor for an image anytime you want in a scene. So I can design all my content around a central anchor, and then I can bring up an image and say, when you see this image, I want you to take all that stuff and move it right on top of the image, right? So this is my invisibility redux, because I think, I don't know exactly what I was trying to say here, except I think the idea is that I need a way to get into the scene without people knowing. And now I have to account for, am I seeing an image or am I not seeing an image? And we'll see how that plays out when I get to the prototype. But turns out you can't see, or what you can't see, you can't gaze track. So remember, I have these 3 planes in my opening scene, and they all are rigged with gaze triggers. They're invisible pings, but we also have a property in Torch, as everyone does, of invisibility. I can turn the visibility of these objects off so that they're off until I see an image that I want to track as an anchor. So I can't gaze trigger what I can't see. You can't gaze at it. What this means is those gaze triggers, the same ones that launch you into the content experience that you want to be in, that's most appropriate for your position with respect to the anchor, won't fire until I tell them to turn visible again. And I can use the image tracking for that, because visibility turns those gaze triggers on and off, which is really nice. The trigger won't fire if you can't see the object. It's pretty simple. So this is rapid prototyping round 3. I've got these 4 scenes again, familiar with these by now. But what I did was I put an image in the main scene to be tracked. And I used the trigger on the scene itself, not on an object, called tracked image found. So what happens when the tracked image is found? It turns on the visibility for my breakpoints, and then my breakpoints are able to be gazed at and trigger me into a scene. Well, that was a mistake. And then what I did was I put the same or the opposite trigger in each of these end scenes, which says when I lose sight of this image, when I can't see it anymore, shoot me back to the first scene, which has the image tracking trigger that will turn on the visibility of these planes. So the effect is I enter into the project and the gaze trigger does not work on those planes until I track the image. And because the image is the anchor, those planes then appear above that image, become visible, fire the right trigger, and then I get shot into one of these scenes. Now, once I'm in one of these scenes, if I lose tracking on that image, all of a sudden I'm back where I started. That's pretty much the run of it. Let's see it. So, yeah, I've got these pentagrams on the floor, and you can see how, there it is. There's my far back viewing. I'm standing, content's on the ground. If I go look at this content much closer, the anchor has been placed very close to my camera, so I stare right through that bottom plane, and I get dropped into the close-up scene. Back at the far back viewing scene. And then this is kind of in the middle. It's just a medium-high table. So what these tracked images are doing is they're basically positioning the anchor relative to me versus the other way around. So we've got options. We can do static. We can do the one-time entry where you're making sort of a one-off sort of static experience using these planes from the get-go, right? Static responsiveness. The dynamic responsiveness that comes with using proximity to objects or proximity to any other anchor or trigger in your scene. And then we've got image tracking, tracked responsiveness. So as we find and lose things, we can change content around. But the most important part is that every one of these is reacting to people. It's not reacting to surfaces and it's not reacting to other content. All of this thinking is based around this idea that people are the ones who are the biggest variable inside any AR experience. And if we're going to start creating content for people to, for mass adoption of this technology, we need to really embrace the fact that the people are the ones that we need to account for most. I could talk about this for hours in a looser context. So if you want to tweet at me, there's my handle. It's Black Mass, that's Black Metal as a Service on Twitter, or you can just find me somewhere in the conference. Thanks.